Hi, I'm Sam Roberts from Roberts Geospatial Engineering, and I'd like to introduce you to ProRaster Scientific version 4.0. So 2025 was a bit of an annus horribilis for me. The family had 3 serious health issues. So I was busy pretty much all year, but I was still coding, and even though I haven't updated the ProRaster Scientific or ProRaster software since March 2025, I do now have version 4.0 in store. And it offers a major new capability platform with 12 new features, improvements and modifications, and a huge number of bug fixes, upgrades to all the supporting libraries. And check out my video on YouTube on the investigation into compatibility with Intel, AMD, and in particular ARM-based CPUs. So the new platform capability is point cloud processing. And point clouds in this context are 2D point clouds. So they're like LiDAR surveys where you're surveying for elevation, for infrastructure, for bathymetry. On the right, I have a map displaying, this is the Central Coast of New South Wales and Australia, and we have a LiDAR survey here displaying as points, coloured by their classification code and with just some OpenStreetMaps on top. So there are 4 capabilities here. Firstly, there's an import capability, and we support 2 different kinds of data: LiDAR data coming from LAS and LAS files, and then general multi-banded point data, which can come from any source. Then we can display that point data. So in a standard MRD rendering algorithm, you can display your points alongside your contours, your imagery, your mapping in 2D, in 3D, etc. using color table modulation or RGB color modulation, with opacity modulation and with clipping, all in real time. Then we have a gridding capability, so we take your points and then convert them into a grid. But this is a very different gridding capability. It implements the operation within a virtual raster. So it's gridding that operates in real time on data sets of unlimited size. And it's quite a thing to see. You're going to really enjoy playing with it. And then you can export those virtual rasters, your gridded data, out to normal raster formats like GeoTIFF, etc. Finally, you can use the dataset to discover things. You can use ProRaster to discover things in your data, and that, of course, is one of the main thrusts of the software, is to enable discovery. So you can integrate your point data and your raster data and your mapping data. You can query the points just by moving your mouse cursor over them and get all the information. And you can filter your points using the LAS filter capability to select particular returns from your pulse return LiDAR data. So let's look at point cloud processing new features. So we have a new file format which supports all these capabilities, and it's called the MRP file format. It's very much like an MRR file format for rasters. So you can put an unlimited number of points, whether it's LiDAR or multi-banded points, into an MRP file. Those points will then be spatially indexed. They'll be stored at multiple scales, so you have an overview pyramid from which you can take data at any scale. And of course, high quality statistics are computed for those point data, and it uses lossless compression. So it's a bit like, for LiDAR data, it's a bit like a LAS file, except that it has these significant advantages of being spatially indexed, multi-scale, and having high quality statistics. We have 2 new layer types in the rendering algorithms for rendering points. One uses color lookup tables, and the other uses red, green, blue interpolation. We have the LAS query editor, which creates global LAS query resources. These are things that you can use when you're rendering points and when you're gridding points. And it will apply a whole set of rules, a cascading collection of rules, which will select returns from each pulse or from your pulse return collection in LiDAR data. Then there are two importing user interfaces. One is to import LiDAR data, and the second is to import general multibanded point data. Those tools allow you to both create an MRP file containing points and to edit and augment an existing MRP file with more points as you acquire them. And then we have the virtual gridding operation, which implements gridding of point data of unlimited size from one or more MRP files in real time. So taking a look at virtual gridding, you can grid point cloud datasets of unlimited size in real time. You can modify your gridding parameters and immediately see the effect. So it's quite a different style of operation to your normal gridding operation. Normally you would go through a process where you specify all of your import data, specify all of your gridding parameters, and then the software just goes away and does all of the work, and sometime later comes back to you with a grid. In this workflow, we import all of our data first and store it into a file, and from that point we can do anything we want with it. The virtual gridding operation will take that MRP file or multiple MRP files, apply your gridding parameters, and in real time grid the data at any scale. So it doesn't matter how large the data set is, you can grid it in real time using this methodology. And then once you're happy with your gridding parameters, then you can use the export function to export your virtual raster out to a standard raster like a GeoTIFF. So you can apply your last filter queries to LiDAR data, pulse return LiDAR data, to select particular returns. For example, you might want ground returns, you might want vegetation returns, so forth. You can clip both the inputs to the gridding and you can clip the outputs. And we have three gridding methods. So the first is nearest neighbor, the second is a Delaunay triangulation, and the third is a tensioned minimum curvature. This is the first time you've been able to use tension minimum curvature on LiDAR data. We augment the tension minimum curvature algorithm with a very special capability, which is a world first, and that's automated trend reinforcement. It's something I've been thinking about for 20 years, and this year I've finally managed to put it into a piece of software. So whilst the minimum curvature iterations are proceeding, it analyzes the trend directions in the dataset and applies modifications to reinforce the trend directions as it grids. So you get a very high quality minimum curvature raster, but with your lineaments enhanced. As you can see in this imagery on the right, we have some aeromagnetic data with these linear features in it, which of course represent geology, and instead of this pearls on a string type effect, we get nice linear anomalies displayed in that grid. Other new features are mostly around processing for temporal data. So it's much stronger now for creating rasters that have a temporal dimension, a time dimension. So there's a raster time sequence operation, which allows you to create a virtual raster with a temporal dimension from some other source rasters. The time differential operation will compute the difference between each of those time points in that temporal raster. But more than just the difference, because you can specify a calculator expression for that operation. And then there's the change matrix operation. To see that in use, go to my website. There's an article about the Annual NLCD dataset. You can see it here. This is a land use dataset for the United States from 1985 through to 2024, and you can see an example of those three new operations being used to process that dataset. In addition, the statistics viewer has been added to the statistics analysis operation and also to the raster source editor, and we have a new HDF5 raster driver which has been trained on the NISAR satellite data. So if you're beginning to work with NISAR satellite data, ProRaster Scientific should be able to help you with that. So that's ProRaster Scientific version 4.0. It's now in the Microsoft Store. You can get a 7-day free trial. Just simply install and use for 7 days without any restriction, and at the end of 7 days you can either purchase the software or uninstall it. So give it a go, and thanks for watching.